everybody, welcome back to another Miss Pollard Math YouTube video. Today we're going to be going over geometric mean, one of our geometry topics, and this is very important when we're trying to find missing altitudes, missing legs, different parts of our right triangles. So let's take a look at what even geometric mean is. So geometric mean is two positive numbers, A and B, can have a geometric mean that satisfies this equation. So there's two ways to go about this. You can either set up your proportion where it's your one positive number divided by x equals x divided by b, cross multiply, or you could just remember the rule that our geometric mean is going to be the square root of our two positive numbers being multiplied together. I'm going to show you the way where we just skip the step of writing the proportion, and we're going to instead just do x squared equals our two positive integers being multiplied together, and then we're going to take the square root of that. So one of the important theorems that we have to know is the altitude theorem, the geometric mean altitude theorem. So the length of the altitude, which is our CD here, it goes from our vertex and creates that right angle, it's perpendicular, is the geometric mean of the lengths of the two segments of the hypotenuse. So our altitude is splitting our hypotenuse into two segments. They're not equal segments, but two segments. Our geometric mean, so our altitude squared, is going to be the first part of our altitude segment that we cut times our second. So we're going to multiply our two parts of our hypotenuse and set it equal to our altitude squared. Then we would have to square root and continue, or whatever portion we're looking for. If we're looking for this, we would do a different portion. But we have to remember the equation that's going to be our altitude squared is equal to our first part of our hypotenuse times the second part of our hypotenuse. Let's take a look at another theorem that's going to be very important to use with geometric mean. So we have the geometric mean leg theorem. So it's saying that each leg of a right triangle is the geometric mean of the lengths of the hypotenuse and the segment of the hypotenuse that's closest to that leg being multiplied together. So what this is saying is our leg squared is going to be equal to the whole hypotenuse times the part closest. So if we're working with this leg, it's going to be times AD. So if I'm squaring AC, I'm going to use the whole, which is AB, times AD. Likewise, if I'm using CB, I am going to multiply the whole hypotenuse and multiply it by the DB. So we're going to take the part that's closest and we're going to multiply it by the whole hypotenuse and set it equal to our leg squared. So this is very important, both of these theorems, to be able to even apply and find the lengths that we're looking for. Let's try an example problem to see exactly what I am talking about here. So now I have this problem, and what I like to start with is using the integer value I have. I'm not going to be able to do anything with all these different variables. I have to look, where's my integer so I can be able to apply it. Well, we have this side length of 12, and we have to figure out what is this side length in relation to the whole triangle. Well, this is a leg, so we're going to use the geometric leg theorem to be able to apply this. The geometric leg theorem tells me that I'm going to take my leg squared, so I'm going to do 12 squared, equals, we are going to take the part closest, x plus 2, and multiply it by the whole entire hypotenuse. So we took the hypotenuse that's closest, part of the hypotenuse that's closest, and we're going to multiply it by the whole entire hypotenuse. Well, our whole entire hypotenuse here is z, but that's not going to help me because those are two different variables, right? So I'm going to actually just add these two. So it's going to be x plus 2 plus x, which gives me 2x plus 2. So I'm going to multiply it by 2x plus 2. Now I'm in the position where we have to think back to algebra, and I am going to FOIL to see what to do. So I'm going to simplify this. I get 144 equals, I get 2x squared plus 2x plus 4x, which is plus 6x, plus 4. I'm going to subtract the 144 over, so I get 2x squared plus 6x minus 140. So now I have to factor this equation. My first step I'm going to do is factor out a GCF. So I'm going to take a 2 out, and I'm left with x squared plus 3x minus 70. And I have to think back. What multiplies to negative 70 and adds to 3? Well, that is going to be my x plus 10 and my x minus 7. So my zeros here are -10 and 7. But if I think about it, I have x. Can my x be a negative value? No, it can't, because I can't have a negative side length. So my x is going to be 7. So if I write this here, this is 7, this is 9. So I did 7 plus 2, which is 9. If I add those two up, my z is the total of the hypotenuse. So it's 9 plus 7, which is 16. All right, I am good to go now with finding those variables. Now I need to find the y and the w. I'm going to do the w first just because I found my two parts of my hypotenuse. It looks a little bit more straightforward to work with. So my altitude, my geometric altitude theorem, tells me that I'm going to take my altitude, which is from here to here, and square it. And that equals my part of my hypotenuse that it's cutting and the other part of my hypotenuse that's cutting multiplied together. So I'm going to do 9 times 7. That gives me w squared equals 63. Then I square root that, and I'm going to leave it in simplified radical form just so it's proper. I can take the 9 out, which gives me 3 square root of 7. And that'll be my final answer for w. And I can write it on here so I recall that. Now finally, I need to find the y. I'm going to use the geometric leg theorem, where I'm going to do y squared equals the part closest to the leg of the hypotenuse times the total of the whole hypotenuse, which is 16. I am now going to square root, so I get y equals the square root of 7 times 16. I know that 16 is a perfect square, so without even plugging 7 times 16 in my calculator, I could take the 16 out. The square root of 16 is 4, so I'm going to get y equals 4 square root of 7. And that's my final answer for y. So in this problem, we used all our different theorems. We used our altitude theorem to figure out what w is. We used our leg theorem, which found out what our y was, what our x was, what our z was. So this was a very intense problem, but once we break it down and we show you how exactly to use the geometric mean, it doesn't seem as scary as it looks. So I hope this was helpful to determine the different parts of a triangle using the geometric mean.